Hey everybody. So I've been a fan of the Zephyr 7B model. It's a slick model and you can do a lot with it. It's very intelligent. And so when I saw today that there was a Zephyr 3B model released, I was quite intrigued by that. And then I saw that immediately that not only is there a 3B release of Zephyr 3B, but that there's also a quantized version by the Bloke. Like the Bloke instantaneously, it seems like as soon as anything comes out, he quantizes it, which is absolutely amazing. So thank you to the Bloke. So there's Zephyr 3B, and then this is the quantized version, and then it's a GGUF quantization. So it's a little bit different quantization method than the other ones that I've shown on this video. If you pay like really close attention to that. But so you have the really simple code using transformers, and then like so you'll need more than this, right? Like this isn't going to get you. This is just the model hosting, but you need like where everything else lies. So what I did was in this repository, if you scroll down, I think I might have scrolled right around here. You've got the code templates for running it in like Python, and then I just took one of the templates from here, and then utilized the code from there, and then built around it, and then it worked well. And then so over here, I've got my Zephyr model, and then so it's pip install transformers, pip install optimum, and auto GPTQ. I probably don't need the auto GPTQ because again, this is running the different type of quantization. And then I have a pip install and accelerate, which I probably still need, and then our model here that's loaded. And then so it's loading in. One thing that I will highlight here is that so for some reason, like, there's got to be something that I can do with the setup here, but it's still, even with the quantized version of this 3B model, using like 12.5 gigs of GPU RAM. System RAM's fine, like 6 gigs, which I would expect, but this is like doubling what I would expect on this side here, and I'm not 100% sure why. But so I played around with the model here. I've asked it a few questions already. What's a few synonyms for a word is the very first one that I gave it. 3 synonyms for the word tiny. And then it says we, micro, and spec. And then what is the capital of France? And then it says that the capital of France is Paris. And this model is really quick to respond. Like, what is the capital of Japan? Just to give you an idea of how quick it'll respond. And then so I think it'll be about like 15 seconds or so, even less. So 4 seconds. The capital of Japan is Tokyo. And then it also does produce this other output here too. So below that, the code provided is a simple example of a chatbot that responds to user inputs. It takes user input, checks if it matches any of the predefined responses, and generates an appropriate response accordingly. In this case, user input is a question about the capital of Japan, and the chatbot provides the correct answer, Tokyo, as a response. And like so, it'll give like I call these like artifacts after every like response or within every kind of response, and like these artifacts like this kind of like residual effect. It's something about bringing the models down to like the 3B and the 1.5B level. Like every model within this range, I notice it does this. Like there's not a way to remove it, and like I don't know, it's just how models in this range are. Why it is in that range, I couldn't tell you. But so I've noticed that it's just common. You expect it from models of this size. Like this is very expected and very common. But other than this, here it is, Zephyr 3B quantized, running in Google Colab. Again, I'm not happy with this almost 13 gigs of GPU, but you can run it in Google Colab. You're not going to be able to run anything else with this because of that 13 gigs of GPU. But I'll try on the back end on my end to see why it's using up almost 13 gigs, and then if I can figure it out, I'll update the Colab. But I'll leave the description to this collab in the description for this video. So if you like this type of content, please like and subscribe. Thank you very much.